In our last class, I taught you how to carry out subtraction of whole numbers. In this class, we are going to see how we can carry out subtractions on decimal numbers. Is that okay? It's a simple thing. All the things you learned from subtraction of whole numbers still applies to that of decimal numbers. The only thing here, just like I told you when I taught you addition of decimal numbers, what you should remember here as a secret when you are carrying out, when you are doing subtraction of decimal numbers, if you have empty place values in the decimal digit part, you are expected, in fact, is a must, fill any empty decimal place values with 0. It might lead you into trouble if you don't do that, okay? Remember I told you this when I taught you addition, and we are going to see how we handle this question. Number 1, okay? Here you have the secrets, what you're expected to do. Evaluate 992.2 minus 503.9. How do we solve this question? You are asked to evaluate. It's still the same as get, find, solve. Are you getting this thing? And get your answer. Let's see. Alright, so we have 992.2. Let me bring out your place values. Because this is in hundreds, okay? We'll have tens and units. Then these are decimal points. This is tenths. This is tenths. But hold on. Watch something here. This 992.2, it's only in one decimal place. This place value is tenths. If you come to this 503.94, this number has 2 decimal digits. In fact, this 9 is under tenths and this 4 is under hundredths. So the smallest place value, which is the last place value here, the decimal part, is actually in hundredths, which means I will take this thing down to hundredths. Is that okay? These are the place values we have for these numbers. Okay, let us start filling up with this 992.2. I'll start with the whole number part, 992. Starting with the unit, you have 2 here, then 9, and then 9. This is 0.2. This is my decimal point. This 2 is under tenths. Okay, then the next is minus 503. Let me put my subtraction sign. 503 is the whole number here, so I'll fill it up in the whole number part. Units here, 3 will enter. The tens, we fill up 0 there, and then 100, we have 5. This is 0.94. Yeah, 0.94, okay? And so we have 0.9, we come under tenths, and then 4 under hundredths. Did you notice that the number 992.2, the hundredths place value is empty? What do? Fill it up with 0. If you don't fill that up with 0, you get into trouble. In fact, you may just fail this question. So I have to fill it up with 0. So let us see what we get from here. Again, we start our subtraction from the smallest place value, from the last place value in the decimal digit part. So we go to hundredths and do that. 0 minus 4 is not possible. See, if this 0 was not written here, maybe you might be thinking that what we have to do is just to bring down 4. It's possible, that's what you might be thinking, because there's no digit here, okay? This is nothing, and then you have 4. Bring down 4. Just like you saw for that of whole numbers, you know. You don't do that here, please. You have to fill up with 0 if you have any empty place value in the decimal digit part. Okay, so we have 0 minus 4. It's not possible, you know. So you're going to add 10 to this. So let me do plus 10. When I do plus 10, this 2 will reduce to 1. This 2 will reduce to 1. So this is 10 plus 0. You get 10 there, then minus 4. And 10 minus 4 is equal to 6. I'm going to write 6 there. If you come to this is 1 now. 1 minus 9 is not possible. So what do? We're going to add 10 to it. So that's plus 10. Plus 10. 10 plus 1 will give us 11. 11 minus 9 is 2. So I'm going to record 2 here. Now, before I cross to the whole number part, take note, when I added 10 to this place, this unit digit will reduce to 1. Are you following, right? I borrowed a bundle, base 10, and added it to this 10th number. So the unit digits, the number there will reduce by 1. Are you getting it right? And so we have 1 there. You know what that means? Just borrow 1 from here. Told you you are borrowing a bundle of 10 actually. Okay, but when you say borrow 1, then this will reduce by 1. Alright, before you move on to this unit place value and continue your calculation, you put a decimal point because you are crossing the decimal points to this unit part now. 1 minus 3 again is not possible. So what do? You add 10 to it plus 10. 10 plus 1 is 11. 11 minus 3 will give you 8. So you have 8 here. Remember that this will also reduce by 1. So you have 8. When you added 10 to this 1, this 9 will reduce by 1. So you get 8 there. 8 minus 0 will give us 8. And then lastly, this 100 place value, 9 minus 5, will give us 4. So we are done. Are you following? Therefore, we can do our conclusion. 992.2 minus 503.94. The answer is going to give us 488.26. So that's how we handle subtraction of decimal numbers. Let's pick question number 2. Of course, that's going to be the last one under the subtraction of decimal numbers. We now want to solve question number 2, the last one for subtraction of decimal numbers. It's about a field, are you getting me right? Measured by Okoli. Now, Okoli measured the area of a field as 17.834 square meter instead of 23.1 square meter. The error in his measurement is dash. We don't know. Okay, now I read this as squared meter. Someone may choose to read it as meter square. Still okay. I prefer reading it as square meter, okay? That is the unit of area. Area is measured in square meter. Now, this problem we are asked to calculate the error in the measurement by Okoli. Think about this. See, the area of the field is 23.1 square meter, but what Okoli measured it to be is 17.834 square meter. Imagine that this marker, the length is 20 centimeter. I asked you to measure it, and then when you were done measuring it, you now told me that what you got is 18 centimeter. But I know very well that the length is 20 cm. So you made a mistake. You measured 18 centimeter. Clearly, you would agree with me that 2 centimeter is missing from your own measurement. If I tell you that the length is 20 centimeter, and you now measure it to be 18 centimeter, you have actually made an error of 2 centimeter. And I got it from 20, the actual length of the marker, minus your own error. So that is minus your own measurement, which was wrong. That is what we are going to do here. To get the error in the measurement of the area of this field by Okoli, we are going to do the correct area of that field, which is 23.1. Then we subtract. We will minus what Okoli measured it to be, 17.834. Now, I will solve this without showing the place values. Is that okay? 23 is the correct area of the field. So I'll write 2 and 3 points. We have 1. Then I'm subtracting minus the measurement by Okoli, which is 17.834. If I write this is the whole number part 17. So it's going to be written under unit and tenths like this. 0.834. This 8 is going to come under tenths. This 3 will come under hundreds, and then 4 will come under thousands. So you see clearly that this 834 has the higher decimal place value. Therefore, I will complete and fill up the empty place value for this 23.1, which is going to be 0 here and 0 here. Let us do the subtraction and see what we are going to get. We're going to start from the last and smallest place value, which of course is thousands, 0 minus 4, it is not possible. So we have to go and borrow. Is that not so? You borrow from the next place value and then add to it. If you are adding, I told you what you are borrowing, what you are adding is 10, because our counting is in tens, So looking at this, if I come to this place value, which is greater than this one, this 100 place value, I cannot borrow from this 0. This is 0 already, I cannot remove from it. So I will still move again to the left. I will come to this one and then borrow from this. I know if you borrow from this one will reduce to what? It's going to reduce to 0. And then take note, as you borrow from this, you are now adding 10 to this 0. Are you following? I'll do plus 10 here, plus 10, plus 10. But that is not all. What I'm solving is not this hundredths place value. Where I'm solving for now is this thousandths place value. So, now that I have 10 here, I can now borrow from this part. You know, it was 0 before. And I told you cannot borrow from 0, so I moved again further to the left. And I saw one that I had to borrow something from 1. And you know, when you borrow, you are going to reduce that thing by 1. If you reduce 1 by 1, you have 1, you remove 1 from it, it will become 0. Then when you are now adding to the place value you are taking it to, you are adding a bundle of 10. Now, coming to this, I will now borrow from this place value and add it here. Are you following, right? And the place value here is hundredths. So I will borrow from there and add to the thousandth that I am working with. Alright, now, so to do that, this is what I will do. This is 10 already, so you will reduce that 10 by 1, so it's going to become 9. Then you come to this 0 and then add plus 10 to it. Good. So we can do the subtraction now. 10 minus 4, what is it going to give to us? We're going to get 6. And then you come to this hundredths place value, 9 minus 3. 9 minus 3 is going to give us 6 again. Now take note, this is 0. 0 minus 8 is not possible. So what do? You come here and borrow. Okay, and if you borrow from this 3, it will reduce to 2. To reduce to 2. As you borrow, you come to where you are solving and then you add 10. This is plus 10. So we are going to get 10 plus 0, which is 10, minus 8. So 10 minus 8 is 2. I'm going to record 2 there. So I'm going to record 2. Now, as I'm crossing to the whole number part, you have a decimal point. So you bring down the decimal point. This is 2. 2 minus 7 is not possible. So what do? You borrow from this place value, so you reduce it. Now, as you are adding to this place value you are taking it to, remember that you are going to add 10. So this is plus 10. 10 plus 2 is 12. 12 minus 7 will give us 5. So this is 5. 1 minus 1 is 0. Forget about it. You know, this is the whole number part, and this is the last digit. So if you do 1 minus 1, you get 0. No need of writing it. And so this is my answer. I can make my conclusion. Because this area we are talking about, the unit is square meters, I said already. So now that I've solved this, I'm going to conclude the error in the measurement is 5.266 square meter. And so this is the error that Okoli made. Is that okay? This question is an interesting one. I'm going to tell you why. Just imagine that you were sent by your parents to buy something and you were given 50 naira. The thing you want to go buy is sold for 20 naira. Are you following? It's sold for 20 naira. So if you give the person 50 naira, the person is expected to give you change. So think about this. You came to me, I'm the one selling that thing. It's sold for 20 naira. You gave me 50. And then when I am giving you change, I gave you 25 naira. And then you now collect the 25 naira with what you bought, you go home. Your parent will flog you. Yes, because the change you took back to them is not complete. It's not complete. I am supposed to give you 30 naira change. If that thing is sold for 20 naira and you gave me 50 naira, I'm supposed to give you 30 naira change, which is 50 minus 20. You get 30. But then if I give you 25 naira, you collect it without telling me, oh, so there is an error in this, you're supposed to still balance me more. If you go back to your parent, you'll be sent back to me. Now, how would you know that there is an error in the money I gave you? The change I'm supposed to give you in that case is 30 naira, like I said. But I gave you 25 naira instead of the 30 naira. How can you quickly know that what I gave you is not complete? You will do the amount I was supposed to give you, which is 30 naira, minus the 25 naira I gave you, which was wrong. And if you do 30 minus 25, you're going to get 5 naira. So if I actually gave you 25 naira, I still need to give you 5 naira more for your change to be complete. That is the idea of this calculation. So you can see that these things are things we see in real life and we do in real life, okay? Mathematics is very interesting. Alright, we are done with this question. You can go through it. You see the way I handled this borrowing here, right? When I could not borrow from the hundredths place value because this is 0, I went further to the 10th place value. And when I borrowed from there, I came to this to add, and I told you what you are adding is a bundle of 10. But remember that the first calculation is this smallest place value, which is thousands. So if you add that 10 from here, you still need to remove from it again. You have to reduce it and add to this place. When I reduced this 10, I got 9. Then added to this 0. And the bundle I added here is 10. Okay, don't forget that is the real calculation. I've told you that already. But even in your own case, you can say borrow one and attach one, no problem. If that helps you out, it's still okay. That is what I used to know. But now I know the real thing I had to teach you. It doesn't mean that if you do your own calculation with borrow one and attach that you are wrong. No, you are not wrong. That is just how you thought about explaining it. It's still accepted. But I've shown you the real calculation, what you should know. Before we conclude this topic, I would like to show you the relationship between subtraction and multiplication. Very important. Is that okay? You need this relationship because of simple equation. Although you're still going to learn about simple equation, but let me just introduce it here a little because of the relationship between addition and subtraction. You see, dear friends, addition and subtraction, they are opposites. Is that okay? Now, if I add these two markers, let me assume that I add these two markers, black and blue marker, and the answer it gave to me is this. Are you following? Or this pink. Now, if this black and blue marker is equal to this pink marker, then this is the answer. It therefore means if I do this answer, which is pink marker minus this blue marker, the answer it will give me is this one, black. And again, if I do this pink marker minus black marker, the answer it's going to give to me is blue marker. Reason, because I added these two markers to get this one. So the point is this, anytime you add two things and it gives you the answer to be a third thing, that third thing, which is the answer, minus any one of the other two things will give you the other one. I'm going to write this on the board for you to see clearly, okay? Now let us assume if you have x plus y and your answer is z. Are you following? Then you notice that I added x and y, and the answer I assume you gave to me is what? Z. Please, I am not telling you that if you add x plus y, you will get z. That's not what I'm saying. I'm just taking x and y to be numbers and z to be the answer you get when you add x and y, as an example. Therefore, this answer, z minus any one of these two you added, will give you the other one. Let me say z minus x. Your answer will be equal to y. And also, if you go the other way around, z minus y. Your answer is expected to give you what? That is good. You will get x equal to x. So take note of this relationship. Very, very important. Once again, you add two things, it gave you the third thing. Now the answer you got, which is the third thing, minus any one of these two will be equal to the other one. That is what I've done here. Now let us quickly look at this example. As an example, if I give you, let's say 2 plus 5. 2 plus 5, you know, is equal to 7. The answer is 7. Therefore, if I tell you 7 minus 2, what will be your answer? 5. That's correct. Therefore, 7 minus 2, the answer is going to give you 5. And what if you go the other way around? Say 7 minus 5 this time around. 7 minus 5. Your answer will give you what? 2. That is good. Now this is very important, okay? And I'm going to try you on something now. Are you ready? Now, remember the rule. You add any two things and it gives you an answer. That answer minus any one of the two things will give you the other one. So, let us go. Okay, now, think of a number. Add 10 to that number. Your answer is equal to 25. What is the number you thought of? How do you get it? Remember I said that number you're going to think of. Add 10 to it. The answer will be equal to 25. So how do you get the number that you thought about? It's simple. You do the answer, which is 25, minus the 10. Remember, you added 10 to that number you thought of. So 25 minus 10 will give you that number. And of course, that number will be 15. Are you following, right? Okay. Think about this one again. Let us assume you are given a number. You don't know the number. Maybe I wrapped that number. I wrote a number on a piece of paper and wrapped it. I now tell you that you see this number? If you add 20 to it, it is going to be equal to 50. Now, what do you think is the number that I wrapped? It's simple. You know that if you do that number I wrapped plus 20, the answer you're going to get is 50. Therefore, the number I wrapped is the answer that I am going to get, which is 50 minus 20. And so that number that I wrapped is 30. That is the good relationship between addition and subtraction. Maybe I might just try you on something on that in the quiz. Is that okay? Very fun, right? This is how we come to the conclusion of Basic Arithmetic Part 2, Subtraction. If you have any question, please feel free to send your question across and you'll get your answer. But then, you may still choose to rewatch the video. Maybe your answer is there in the video lesson, so you can rewatch it, okay? But if you think you now understand everything that you have been taught, if you understand everything that I've taught you so far under subtraction, then below this video lesson, you have the lesson note. And after the lesson note, you see the quiz on this topic, subtraction. Take the quiz and remember our target score, 10 over 10. Alright? If you get 9, don't stop. Try it again. Try the quiz again until you get 10 over 10, okay? When I meet you in our next class, I'll be teaching you multiplication of whole numbers and decimal numbers. Until then, please make sure you study your books and get prepared, alright, for our next class. You can take other quizzes you have on the topics we've done so far in preparation for our next class.